guys, welcome to Deep Course, and in today's video we will discuss LeetCode question 1443 that says minimum time to collect all apples in a tree. So here you are given a tree of n vertices starting from 0 to n minus 1 and you need to collect apples. So the vertices have apples in them, and you have to travel from vertex 0, collect all the apples and come back to this vertex, that is come back to vertex 0. Further, the time to travel one edge, that is joining between two vertices, is 1 second. So you will spend 1 second to walk over one edge of a tree. Okay, and further the tree is given by edges representation, where the edges between two vertices are given, and the has apple is a boolean array where that states that does the index I vertex has an apple or not. So here index 2, 4 and 5 has apples, and n states the total number of vertices. So let us now take a look at this first example. So initially we are at vertex 0 and there are apples at vertex 2, 4 and 5. We need to collect all of them and again return to 1. So one of the efficient answer, as we need to return minimum time, so one efficient answer is travel from 0 to 1, 1 to 4, then collect this apple, again 4 to 1, 1 to 5, 5 to 1, 1 to 0, 0 to 2 and 2 to 0. So this will totally take 8 moves, and each move take 1 second, so 8 seconds we return as our answer. So I hope you guys got the question and what we have to do. Similarly, there are 2 more test cases, you can go through them by yourself. So let me give you what intuition you have to build after looking at this question. So first thing, they have told that you are given a tree, but they haven't mentioned anything about is the tree is binary or not. So you have to consider this as a graph that doesn't have a cycle, that means no cycle, plus you can travel both the way, like from 0, if there is an edge from 0 to 1, then you can travel from here 0 to 1 as well as from 1 to 0. So you can take this as a bidirectional graph. Okay, so I hope these things are clear, that thing is as a graph with no cycle and bidirectional edges. The second thing to note here is there are apples on vertices. Okay, and there is no fixed pattern of numbering the vertices. So as you can see here in the first example, the vertex 3 should come here if it is a binary tree, but it is anywhere, so there is no fixed numbering. So if you are standing here, then you don't know, let's say if you are standing at the vertex 2, then you don't know does the child have an apple or not. So this means you have to traverse all the vertices. So first thing is you must do is traverse vertices, all vertices. So for traversing, what you would do, either you can do DFS or DFS. Okay, so I hope till here things are clear, that make a graph. So for graph you can build adjacency matrix of size n, and here you will do traversal. And third thing you must note here is we have to again travel back to node 0. Let's say if you start from node 0, then you have to again travel back. So you have to maintain some variable for time as well. Okay, so I hope things are clear till here. Now let us move to approach of how we would solve this question. Okay, so the first thing what we would do, as we discussed earlier, that we would do traversal. So here let me take as DFS traversal. Let me make adjacency matrix of size n. So inside a DFS traversal, and let me also take one visited boolean array. Okay, so inside this DFS traversal, what I will do, first let's say this is a function where I took adjacency matrix, then that apples array, then visited array as an input, and another input, that's it. Let's say let me name it as node. So initially the node value is 0, so these are the input. We would travel it, so we would firstly make visited of node equals to true, then traversal with a for loop for child. Okay, and We will also initialize one sum variable, one time variable. Let me name it as time. And here for traversing a child, we would store its value. So this will return int. And what here we would write a condition that if apple of node or this time greater than 0, then what we would do, return time plus 2. So let me now else we would return 0. So let me just explain you this logic with an example here. Let me build one graph here. Okay, and let me give some of this starting. I am doing starting on the nodes that have apples. Okay, yeah, so initially we are at 0th index, so here time is 0. So here, as you can see in the function, we haven't maintained any time variable, but only we are checking it here. So what thing we are doing is, so whenever we hit any apple, as you can see here, if let's say we from 0 we traverse to 1, now then we traverse to 1 child, that is 3. So here this vertex has an apple, so if we have an apple we would return time plus 0. So for 3, time variable would be 0 plus 2, so it will return 2. So here 3 has returned 2. And you must be thinking why 2? Because from 1 to 3 traversal will take 1 second, and again 3 to 1 will take another 1 second, so we return 2. Now from 1 we will traverse to 4, then to 5, then again to 4 as there is no child, then to 6. Now 6 has an apple, so we return again 2 here. Now this will, now from 4, if at many vertex child has returned something, if time, then that means time is greater than 0, and if time is greater than 0, then again return 2, because to travel from 1 to 4 you would require 1 second and again 1 second to return. So we would, what we would do is we would return 2 plus 2, that is 4 here. So this is how this logic is working. So I hope you guys now understood why we wrote this logic. Means if we have an apple at the node, or if any of the child node has an apple, if a child node has an apple, then time would be greater than 0. So and then this will return here 4, and this 2, 6. So what we return 6 plus 2 here again. So total here 8 seconds. Here this will return plus 2, that is total 10 seconds would be our answer. This would be our final answer. You can trace it yourself, like 1 second to go from here, then here 2 seconds, again here 3, 4, 5, 6, 7, 8. So this is how we return it, then 9, 10. So this was the traversal of this graph by using DFS, and this was the logic. So time plus 2 is because we are also have to count the time to go back to its parent. So this is why. So I hope you guys understood the logic. Now let's move on to the coding part. So let me first make adjacency list, vector int adjacency of size n for auto all edges e of 0 dot push back e of 1. Also the edges can be bidirectional, so I'm pushing back from 1 to 0 edge. Okay, now I will also make one boolean visited array of size n, and let me initialize all values as false. Now I will take one answer variable and call a solve function where I would pass adjacency matrix has apple array, visited array, and initial node, that is 0. Let me now code this solve function that takes adjacency matrix, boolean array, let me name it as apple, boolean array, visited, and int node. So for better for memory management, let me use n%, so this won't create the copy of that vectors. So initially what I will do, if visited of node means if we have visited node, then I would simply return 0 as what visit the node and may mark it as true. Initialize one time variable is 0. Now for all its child of this node, what we would do is we would do time equals to solve and, pass and traverse for the children visited, and instead of not pass child, that means we are traversing the children. Now if we get if the current vertex has an apple, or the time is greater than 0, then in this case what we would do to return time plus 2, and as the else situation we would return 0. Okay, so that's the code, and in the end here we would return our answer. Now let me try to submit this. Okay, we got wrong answer here. Let us try to check it. Okay, so I think here time plus equals to 0 will come. Also, if the node equals to 0, that is initial node, then we would simply return this time. Because you can think yourself, if you found an apple at this initial node, then for that apple the time would we won't increment by 2. Got it? So that was that condition we have to handle. So let us try to run it again. Okay, now it passed all the test cases. Let us try to submit this. So yeah, our code passed the test cases, and now let us discuss the time complexity. So here as we are traveling or the n nodes or n vertices of the graph, so the time complexity is big O of n, as well as we are making a DFS call, so this stack will also consume some space, so that will also make a space complexity of big O of n. So I hope you guys understood the question, the intuition part, our approach, and also the coding part. So that's all for this video. Make sure you like the video and subscribe to our channel. Thank you.